Thanks for joining me. We're going to go through lots of examples of nomenclature today where the problems will be mixed up and we'll sort of figure out how best to solve these problems. So I'll demonstrate that all for you. So we're going to go ahead and get started. We're going to first start with just a bunch of ions to begin with, metal ions. So here they are. All right, I've just listed a bunch here: iridium, calcium, titanium, platinum, barium, and so on. Now, the first thing you need to do is determine, is the metal ion, what you're looking at, a fixed charge or a variable charge? Now please recall that if it's in group 1, group 2, silver, zinc, or aluminum, it's fixed. Everything else is variable. So that means iridium is variable. Calcium is an alkaline earth metal, so it is fixed. Titanium, variable. Platinum, variable. Barium, again, alkaline earth metal, that's going to be fixed. Strontium, alkaline earth metal, fixed. Potassium, that's an alkali metal, fixed. Zinc, remember, silver, zinc, aluminum are fixed. Manganese, variable. Gold, variable. Sodium's an alkali metal, fixed. So the first thing we've done when we look at a compound is we look at the metal and we decide, is it fixed or variable? Now, if it's a nonmetal with a nonmetal, we just use the Greek prefixes. Those aren't going to be addressed at this point. Now, iridium, I've looked these up, could be +2, +3, +4, or +6. Calcium is always and only +2, so we don't have to do anything with that one. Titanium could be 3 or 4, platinum 2 or 4, barium is always +2, strontium's +2, potassium is a group 1, it's a +1, zinc's +2, manganese isn't very picky, +2, +3, +4, +6, or +7. Gold can be 1 or 3, and sodium only a 1. Next, we need to pick out the charge for one of these, and there's not a right answer here, so I'm just picking 3. So if I use the iridium and the 3+, the name will be iridium 3 something. Calcium, it's a fixed charge, so I just say calcium. I don't put the Roman numeral 2 there. In fact, if you do put the Roman numeral 2, it's wrong. Now we can pick 3 or 4. Just tell me which one you want. All right, 4 it is. How about the next one? 2, sure. Next one, notice it's fixed, so I just say barium. No Roman numeral needed. Strontium is fixed. Potassium is fixed. Zinc is fixed, so I don't use a Roman numeral. Manganese, we can pick 2, 3, 4, 6, or 7. Which one haven't we used? Well, let's go with 4. I know we've used it, but I just went ahead and put a 4 down there nevertheless. We can go 1 or 3. Let's go with a 3 here. Again, we could pick any one. That's not the game we're playing. We're just identifying a particular ion. And then sodium is going to be fixed, so no Roman numeral. Next, we're going to go ahead and add a formula here. So IRF3 would be iridium 3 fluoride. It's a binary compound, meaning it contains 2 elements, and it's going to end in IDE. On the next one, if I have CAS, well, that's a binary compound. So how about calcium sulfide? Next one, TiS2. Now, you might want to call this titanium 2 sulfide, but in fact, it's titanium 4 sulfide. Each sulfide is -2, and there's 2 of them, so that's 4 negative charges. So the titanium is +4. The next one, PtCl2. How about platinum 2 chloride? Next one, barium bromide. Next one, strontium phosphide. Notice these are all binary, so we just name the metal, name the nonmetal, drop the ending, add IDE. Continuing, potassium with fluoride. How about potassium fluoride? Zinc with iodine, zinc iodide. Manganese 5. Well, manganese and chlorine, that's not a 5, first of all, that's a 4. How about manganese 4 chloride? And this one, gold 3 oxide. And finally, sodium phosphide. Okay, so this is demonstrating for you a bunch of binary metal, nonmetal combinations. And what we had to figure out was, is the metal variable or is the metal fixed? If it's variable, we use a Roman numeral. If it's fixed, we don't use a Roman numeral. Now, realistically, you'd be given what's on the left, the overall formula, and then have to come up with the name. But in your mind, you have to figure out if it's fixed or variable. All right, let's try some more. Let's get rid of that, get rid of that. And this time, let's add some polyatomic ions. Now, you probably want to have your polyatomic ion sheet out to kind of go through this. I'll be going kind of fast, and you can pause as quickly as you want to see if you can figure it out. Cr2O7 is called the dichromate ion. So this one is iridium 3 dichromate. The next one, this is a hydroxide. So how about calcium hydroxide? This CrO4 is called the chromate ion. So titanium 4 chromate. This one is called the acetate ion. So platinum 2 acetate. This one is called the bromate ion. ClO3, 1 minus is chlorate, so bromate is BrO3. So how about barium bromate? SO4 is sulfate. That's another polyatomic I asked you to memorize. So that's strontium sulfate. Cyanide is one of the exceptions that I had you memorize, so potassium cyanide. This one, nitrate, is NO3, 1 less oxygen, nitrite. So this is zinc nitrite. Now don't be kind of silly and call it zinc dinitrite or something like that, right? And try to use the mono, bi, tri, tetra. Don't do that, right? That's only if you have two nonmetals. Next one, I have a chlorate, ClO3, so manganese 4 chlorate. Now I have a phosphate, PO4, another one that you're supposed to memorize. So gold 3 phosphate. Don't call this gold phosphorus tetraoxide, okay? This is a polyatomic, leave it alone as it's written. And finally, NO3 is another polyatomic I asked you to know. That's nitrate, so sodium nitrate, okay? So you can see the game still is the same. If the metal is variable, it needs a Roman numeral. If the metal is fixed, it does not. But instead of making these binary, I use polyatomics. And notice that they all end, with the exception of hydroxide and cyanide, those are exceptions, they end with ate or ite, which is how polyatomics will end. Let's see what comes up next here. All right. Well, this one we already went through, so we're not doing that again. I don't know why it came up twice. All right, so let's talk about organization system here, right? Because oftentimes the reason you're confused is you don't have a good system to keep this organized. Now, everyone at their house has like, some organization. There's probably, a drawer where you keep your bills, a drawer where you keep, I don't know, pens or something. And then of course you got that junk drawer that everything else goes in, right? Scotch tape and rubber bands and things like that. Well, in our system, we're only going to have 3 drawers in our organization, okay? Just 3. And here they are. The first drawer, and I'm going to call this slide, where would you file this? The first drawer is 2 nonmetals. That's relatively easy to determine. If you have 2 nonmetals, it's going to go in that system. The next one is if you have a multiple charge cation. In other words, a metal with a variable charge. So it's either 2 nonmetals or a metal with a variable charge. And then I said there's only 3 drawers, everything else. Okay, so let's talk about the details of this. For 2 nonmetals, we use Greek prefixes, mono, di, tri, so on. For the charge, you don't worry about the charge for 2 nonmetals. So forget about that. And of course, crisscross rule with nonmetals, don't need that either. You just say what it is using the Greek prefixes. Now, do you use Roman numerals with nonmetals? Nope. Again, the only thing you do with two nonmetals is say the Greek prefixes. Now, if you have a metal with a variable charge, that's the stock system, you're going to use a Roman numeral for the charge on the metal with the name of the metal. Polyatomic ions, that's okay. You can have a metal with a variable charge and a polyatomic ion. Well, what does that leave us? Well, what it leaves us is everything else, which is metal with a fixed charge. So Roman numerals are not needed there. Now, we also have in our everything else bucket the old system of ich and us. And of course, we can still use polyatomic ions with any of those as well. So here's our list. We're going to kind of go through in order and check these things out, okay? Let's start with VCrO4. So the first thing I look at is the V, the vanadium. Is that a metal or non-metal? Well, look at it on the periodic table. It's a metal. It's not group 1, it's not group 2, it's not silver, zinc, or aluminum, so it's a multiple charge cation. Okay? So how would I name it? Well, name the metal, use a Roman numeral, and name the polyatomic ion. Well, CrO4 is a 2- polyatomic ion called chromate. And there's one of those CrO4s at 2- and one vanadium. So the vanadium, to make this neutral, must be +2. So I would go with the name vanadium 2 chromate for VCrO4. Okay, let's try the next one. The next one we want to deal with is dinitrogen pentoxide. Now, as soon as I see the di and the pent, I'm thinking, that looks like Greek prefixes, so that's two nonmetals. So I'm going to move it up here. Now, it says, don't worry about the charge. I don't have to crisscross, no Roman numerals. I just state what it is. So di means 2 nitrogen, pent means 5 oxygens. So how about N2O5? That is dinitrogen pentoxide. Okay? See how this works? This 3 little drawer system? All right, next one, BaO. Well, barium is a metal. It's in group 2. So it's a fixed charge metal. So it's not two nonmetals. It's not a multiple charge. It's an everything else. So it goes up here. Now, it says don't use Roman numerals, and I don't have any polyatomics. So simply name the metal barium, name the nonmetal oxygen, drop the ending, add IDE because it's binary. So barium oxide. That's BaO. All right. Hope this is making sense. Let's try another one. Next one, platinum 4 iodate. The fact that I see a Roman numeral, I don't use Roman numerals for two nonmetals. I don't use it for everything else. So the Roman numeral tells me it's a multiple charge cation. Now, that Roman numeral is the charge on the platinum. So the platinum is 4+. Then I have an ending that ends with ATE. That indicates a polyatomic ion. Now, I memorized chlorate was ClO3 1-, and so therefore chlorine and iodine are both halogens. So IO3 1- is iodate. So I got a +4 and a -1. So when I do the crisscross, I'm going to need 4 of the iodates, and be sure to put that in parentheses. So it's going to be PT parentheses IO3 4. That's platinum 4 iodate. All right, we're getting there. CBr4. Now, carbon's a nonmetal. Bromine's a nonmetal. So this is two nonmetals. So we simply use the Greek prefixes. Remember, the prefix for one is mono, but we don't use mono for the first item. So this is simply going to be carbon tetrabromide, because tetra means 4. So carbon tetrabromide, that's CBr4. Next, ammonium chlorate. Ammonium's not a metal at all, but it's also not just two nonmetals, Ammonium is a polyatomic ion, and chlorate is a polyatomic ion. So this is an everything else. Now, if I've memorized these, ammonium is NH4, 1 plus, and chlorate is ClO3, 1 minus. So they can get directly together. NH4, ClO3 is ammonium chlorate. Next one, niobium is Nb. That is a metal, and it's not a fixed metal, so it's a multiple charge. So how do I figure the charge on the metal? Well, I look at what it's attached to. Now, I know that ClO3, 1 minus, is chlorate, and if you add one more oxygen, that's perchlorate. So ClO4, 1 minus, is perchlorate, and I have 5 of them. They're each minus 1. So that's 5 negatives, and I have only one niobium, so it must be plus 5, or niobium 5 perchlorate. That's the name of that, NbClO4 5. Next, potassium iodide. Potassium is in group 1. It's an alkali metal. So it's not a 2 nonmetal, it's not a variable charge, it's an everything else. K is 1 plus. This is binary because it ends in IDE, so that's I1 minus. K1 plus, I1 minus, Ki. That's potassium iodide. Next, SCl2. Well, sulfur is a nonmetal, chlorine is a nonmetal, so that's going to be up here 2 nonmetals. So use the Greek prefixes. You got 1 sulfur, so just say sulfur. You got 2 chlorides, so that's going to be sulfur dichloride, SCl2. Next, nitrogen trichloride. As soon as you see those prefixes like tri, you got nitrogen a nonmetal, chlorine a nonmetal, that's 2 nonmetals. Now, it doesn't say di or tri, so there's only 1 nitrogen, so 1. But there's 3 trichlorines, so NCl3 is nitrogen trichloride. We'll continue. We have rubidium. Now, rubidium is a fixed charge metal with a polyatomic. So it's an everything else, isn't it? Now, sulfate is 2 minus, rubidium is 1 plus because it's an alkali metal. So simply name the metal rubidium, don't use Roman numerals, and this is a polyatomic sulfate. So rubidium sulfate. That's the name of Rb2SO4. And finally, this last one should just jump out at you. As soon as you see the Roman numeral, you know you're dealing with a multiple charge cation. The manganese in this case is plus 5. That's what that Roman numeral says. And this is a binary because it ends in IDE, so sulfur by itself. That's a 2 minus. A 5 plus and a 2 minus, when they crisscross, gives you Mn2S5. Okay? All right. I hope that helps. I'm going to give you a little practice here to do. And if you use this little system, I think it'll work. Even if you just have it in your mind, it'll work pretty well. Right? All right. So here we go. So this is a practice quiz. So I won't walk you through anything. It's not for real. You don't have to turn it in. Just pause the video, take some time to try to answer those questions. Then, when you're ready, unpause it, and I'll go through the answers. So that first one, when you crisscross, should be Al2S3. And the name of that, if you wanted, aluminum sulfide. It wasn't asked, but we could put that down. The next one, leave the boy band alone. Don't touch the PO4. The 2 comes down, the 3 comes down. So you get Mg3, parentheses, PO4, 2. And the name of that, magnesium phosphate. All right, now we want to go, if I give you the name, I want the formula, name. This first one is a binary. You got a fixed charge metal, so how about barium oxide? The second one, you got a fixed charge metal and a non-metal, so how about LiBr? Lithium's 1 plus, bromide's 1 minus, LiBr. Nickel, it's a variable state metal, so you have to figure the charge. sulfur's -2, and you have 3 of them, so that's 6 negatives. And you have 2 nickels, and to get 6 positive, each nickel must be a 3 plus. So let's call that one nickel 3 sulfide, because we've got a binary compound. It will end in IDE. Anytime we see these Greek letters, these Greek names in front, we know it's 2 nonmetals, so we just say what it is, no crisscross. Tri means 3 phosphorus, so P3. Hept, you got to help me on that one, is 7, so O7. So P3O7. The next one, I've got a nonmetal nitrogen, nonmetal oxygen, 2 nonmetals. I simply use the Greek prefixes dinitrogen, pentoxide. I've got a Roman numeral here. That's not 4, it's Vi, that's 6. So molybdenum is +6. This ends in IDE. That means it's just nitrogen by itself. So nitrogen is 3 minus, and maybe we'll write that out. So you've got here, we'll do it in red. I don't know, I thought my pen would work. Maybe it won't. All right, forget that. We thought that would work. So molybdenum is 6 plus, nitrogen is 3 minus. I'm going to need 2 of the nitrides. So how about MON2? All right, the next one we haven't really gone through, but let's just see if you can make sense of this. Write the total number of atoms that make up each compound. Well, you got 1 carbon plus 3 hydrogens is 4, plus 6 carbons is 10, plus 2 more is 12. And then, so we got 12 here, and then you got 1 N and 2 O's. That's 3 atoms, times 3 is 9, plus 12. Can you see where that 21 comes from? So it's really a question of, do you understand what is happening at the end here? For phosphoric acid, you have 4 oxygens, 1 phosphorus, that's 5 atoms, plus 3, that's going to be 8 atoms there. Now, if I remember, there might be a mistake on this one. Let's see if you can figure it out. If lead is +2 or +4, the old system, the ic ending, is the higher number. So we must need lead +4, and iodide is I1 minus. So how about PbI4? Looks correct to me. What would that be in the stock system? Well, how about lead 4 iodide? All right. Now, finally, I've got just a little bit of time. I'm going to go ahead and review with you all of the systems here. Now, this will be a pretty quick review, but it should be a pretty useful review if you're still with me. Here we go. If you have 2 elements, you could have a metal that's fixed and a nonmetal. The fixed metals are group 1, group 2, silver, zinc, aluminum. In order to name these, you name the metal, name the nonmetal, drop the ending, and add IDE. All binaries will end with IDE. So an example of this would be sodium chloride. Sodium is a fixed charge metal with a nonmetal chlorine. Now, you could also have 2 elements where the metal has a variable charge and a nonmetal. For these, this is the stock system, we need to use a Roman numeral. So the metals that are variable are groups 3 through 12, those transition elements, and then like tin and lead, there's a few others that are variable charge. So we use the preferred method for a metal that's variable charge is the stock system, where the Roman numeral is the charge on the metal. So here's an example, chromium 2 chloride. The chromium is +2, and it's with chlorine, so chromium 2 chloride, okay? Once you got to the charges, you could have easily crisscrossed, the 2 comes down, the 1 comes down, to get back to check our answer, CrCl2. Now, we also have the old system, the one that's not preferred for metals that have a variable charge. Now this only works if there's 2 oxidation states, and we have to use the old Latin names of the elements. The higher oxidation state will end with an ic, the lower one with an us. Again, O and lower, O and us, I, they go together. Okay, so here are the old Latin names of the elements. Tin is stannum, lead plumbum, copper cuprum, gold aurum, iron ferrum. So if you're using something like iron in the higher state, you're going to say ferric. Don't say ironic. That's not right. So CuCl2 is cupric chloride. Well, if I looked up at coppers +1 and +2, then I noticed that I have the higher one +2 because I know chloride is -1. There's two of them, two negative charges, and I have only one copper. It's the +2. Hence, it gets the ic ending, cupric chloride. Don't call it cupric Roman numeral 2 chloride. Don't combine systems. That would be marked wrong as well. Now, if you have three or more elements, we're talking polyatomic ions, then we call these ternary compounds. You're going to just use the name of the polyatomic ion. Now, they will tend to end with the letters ATE or ITE. And again, I tried to show you that pattern. If you remember, here's lithium nitrate. And again, the only cation that's positive polyatomic ion is ammonium, NH4. Otherwise, it's going to be the last two elements are the polyatomic. Now that's different than lithium nitrite. Remember, one less oxygen is the ite, one more is the ate. And if you have one more than the 8, that is the per-ate. And if you have no oxygens, just a binary, it's going to end with IDE, lithium nitride. All right, here's the pattern that we looked at. We said you need to memorize those polyatomics. Chlorate, nitrate, carbonate, sulfate, phosphate. I call them the 8 eighths. Well, there's the 5, and there they are, okay? And then also I said memorize these three exceptions, ammonium, cyanide, and hydroxide. They're still polyatomics, but these two end in IDE, and this is our positive cation one. Now, if you memorize these normal ones, those are the ones that end in ate. One less oxygen will always be in ite. So chlorate becomes chlorite, nitrate, nitrite, and so on. Notice the charges stay the same. Only thing we've changed is one less oxygen. Now, if you go two less oxygens, that's then the normal. Then we use the suffix hypo with ite. So hypochlorite, ClO1-, hyponitrite, NO1-, and so on. And finally, if we go one more oxygen, then that's a per-ate, kind of like hyper, but we just say per-ate. So the charge remains the same. Perchlorate, ClO4, 1-, pernitrate, NO4, 1-, and so on. Some of these don't even exist, but the beautiful thing is if they did, we know how to name them. Now, these are the only ones I need you to have memorized. Everything else, like a dichromate or an acetate, I would give you on the test to use. All right, let's finally figure out how many atoms are in a formula unit of ammonium hypophosphite. Now this is a challenging one. In order to do this, we need to come up with a formula first. So ammonium is NH4 1+. Now phosphate is PO4 3-, phosphite PO3 3-, hypophosphite PO2 3-. So I put that in there. Now I got a 3- charge and a 1+. So that means I'm going to need 3 of the NH4s, and I'm going to have to put that in parentheses. Now to figure out how many atoms are in this formula unit, in NH4, that by itself is 5 atoms, and I got 3 groupings of that. That's 15 atoms, plus the 1 from the phosphorus, 16, plus 2 more. So I would go with, if I want to get it right, 18 atoms. And then, of course, finally, we have nonmetal, nonmetal. Use the Greek prefixes. Don't reduce. Just make sure you memorize those, and don't use mono for the first one if you have 2 nonmetals. All right. When you take your quiz, your test, I would give you ones like this that I wouldn't expect you to know. All right. That's it. Hopefully that was a useful review for you. You may want to watch this one a second time just to really let it sink in and make sense for you. Good luck with all your nomenclature. Thanks for all your hard work. Bye-bye.